All right, cool. Hello. My name is Adam. Her name's Nellie. We're here today to teach you about Game Boy assembly language programming. Uh, there's just nothing like petting a cat that's slumped over your arm. It's truly the greatest feeling in the world. So yesterday we I'm making like a breakout game or whatever. Yesterday we added these indestructible blocks, like those that you see here. It's weird. I don't know why that one didn't get destroyed. Anyways, I'll have to check that. Hi. Hi. Are you perfect? She's perfect. It's great. So yeah, yesterday we added these indestructible bricks. Having done that, um, what are we doing today? Today, there's a bug I need to fix regarding the indestructible bricks. Um, there's a to-do I want to take a very quick look at that should take no more than 10 seconds to knock out, just related to the sound engine. And then after that, I'm going to start writing a Python script to generate the bricks. Right now, hi Nelly. Hi. Right now, um, right now, I've just am manually typing out the graphics in here, which is obviously not ideal. So I'm going to write a conversion script, which is going to take this, let me zoom in a little bit, the different brick types, and generate, each brick is 8 pixels across, 4 pixels up and down. It's going to take these and it's going to generate all the possible combinations for 8x8 bricks, and place them into the sort of appropriate slots in VRAM, so to speak. Hi, Nelly. How you doing? She is an absolute queen. Hi, Mom. Oh my gosh. Yeah. Uh, Maybe I'll eventually get to work, but mostly I'm just going to be petting the cat. Right. So bug fix 1. That was in stage, I believe. Yes. So right now we've got a bug where we compute the total number of bricks in the level, and we use that to determine when you've beaten the level by tracking every time you destroy a brick. But because we introduce these indestructible bricks, we don't want to include them as part of the total count. So we just gotta add some code to adjust to account for that. Nelly, I'm not gonna be productive at all, but it's okay because you're perfect. Uh, so this is actually a really easy fix. All we need to do is just add a little comparison here. And similarly over here, so that we're only counting the bricks that matter. I'm just going to build this real quick. Nice. I'm going to hit reload and hit run. And instead of actually playing it to test it, I'm just going to go to, what is this? Total bricks, I believe, is the name of the variable that I want to check. That is set to 6, and we have 1, 2, 3, 4, 5, 6 bricks. Perfect. That is the fix. The fix is in. So we're going to save that in a commit. So all we're doing here is, this is straightforward. We take a look at the 8x8 tile, we mask out the top because we're just checking the bottom, and we compare it to 1, which is the ID number of the destroyable bricks. And then if it's not 1, we're just going to skip it. And then we do the same thing for the top. We mask out the bottom. Now we have to, actually, I don't need to swap. So let me make this ever so slightly faster. We're just going to compare the top brick to 1 in much the same way. There we go. That saves us an instruction. It saves us 4 cycles. Ignore indestructible bricks when computing closeout bricks. There we go. Bug fix in. The next thing I wanted to do is I have this to do. Move sound engine to a separate bank. This is actually really, really easy. There's no good reason for me to not have just done it. Nelly, do you want to go? Okay. Bye, Nelly. I'll miss you. Now you're stuck with my dumb face instead of my cat. I am sorry. Sound system. What do I want to define? I want to just go into here and I want to set this to sound system code bank to 1. And the reason I want to do this is because on the Game Boy, the bank 0, which is the default location for the sound system, is very privileged space. It is the space which you never need to bank switch to access. It is always accessible. And so you really only want to put stuff in there that absolutely has to go in there. And so if I just go take a look at this map file, which shows how much free space I have in any given bank, you can see right now I've got just over 2.5K free. K? No. Whatever. I've got this many bytes free. And that's because, in part, because a lot of the sound system stuff is getting put into there. So I'm just going to, the only thing that'll need to change is that every time we call into the sounds, I'm going to build, but not run it, because this is still kind of broken. Because we're now going to need to manually switch banks into the sound system bank. But what this does mean is that because I've made that change, now the, oh god, where is the, yeah, we've freed up about 800-ish hex bytes, which is awesome. And that's just going to let us use the home bank for more important things. The only thing that's going to need to change is that every time I make a call into the sound system, which I believe happens where? I think it only happens in busttree.asm. We're going to need to, yeah, into this, and into this, and here, we're going to need to switch banks into the sound system bank, which is no big deal. Let's get the bank, sound system process, write it into hex 2000. That tells the memory controller to switch banks. And we're also going to need to do that here. Luckily, I believe that we don't need to do that again for the music play because we've already switched banks. So that should work. I think that should do it. I'm gonna have to enable sound for this. I hope it does. This doesn't like play horrible noise. Because I like broke the sound system or something like that. That's not great. That's not great. Where is that happening? That is happening, well, in the sound system code. That is happening in the sound system code, but I don't really have a clear idea of why it would be doing that. Accessing inaccessible VRAM. That's even stranger. Why is BC pointing into VRAM right now? We go take another look at these defines and see if there's anything interesting here. Yeah, sound system init. Oh, did I screw up? Is there another place? Oh yeah, sound system init. Maybe that's where I screwed up. Let's see if that helps. Was, in the ROM, run. Nope, same results. Well, it's still an improvement because we do need to switch banks. Am I missing something here about the nature of the sound system? If I go look at sound system, must be legal when all of the definitions specified in this file take into consideration. It's up to you to change ROM banks before and after making any sound system call. Sure. Well, that all seems fine. I don't see why this is causing a problem. Are there any other defines? No, I don't think so. Oh no, I don't want this. I mean, what is this? Yeah, it's just, things are just going crazy here, which doesn't make a whole lot of sense. Did I miss any of these? Well, let me reset and just step through this to see what's going on. So I'm just going to step over here. I'm just going to yada, 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 yada. All this is fine. All this is fine. So far, so good. It's just when we start to play the music that things blow up. I wonder why that is. That's so strange. I don't have a. It might just be a bug in the sound driver. Or something to do with. Yeah, load a bank sound system process. Load into 2000 sound system process. It might have something to do with the fact that the song that I'm playing is too large and doesn't fit in a single bank. I'm going to open up this. I'm going to go GB sound system. I'm going to go see if there's any issues or bug reports. Nothing here. Prepare for release. So nothing here has changed. I'm not sure. I'm going to need to research this at another time. So that's annoying, but it is what it is, I guess. Let me actually just double check one other thing. sound system process. That's the main driver here. Registers will not be preserved. Yeah, none of that is an issue. I don't know. It might be. It's hard for me to say. So I'm gonna just revert those changes because I don't know what's going on. So unfortunately, we don't get to fix that for today. So instead, what are we going to do? Whoops. Instead, we're going to do some Python programming, I think. Python is just pretty good for hacking together stuff real quick. Write a conversion script to auto-generate tiles for all combinations of bricks. That's what we are going to do. So I'm going to hit Control N. We're going to call this like, nope, up here. We're going to go Python. We'll call this like make tileset.py or something like that. I'm going to go search for a library for interacting with ping images in Python. No, I don't trust Bing for this. I'm going to consult Google. I guess PyPing is what I probably want. I'm just gonna go grab code ping.py and just use that because that is apparently all I really need, supposedly. Alternatively, you can copy code ping.py wherever you like. Intended, you can copy ping.py into your application and distribute it. So I'm gonna use that. Just makes it easier to deal with if I just have one file that I'm working with. Raw, let's save it. Ping.py. Show on folder. Let's grab that, bus tree, copy that into there. I should also probably organize things into some kind of directory at some point, but whatever. We import ping. I'm gonna have a main function. I'm gonna do the old, if name equals main. I'm gonna bother with this. And then what am I going to do? I'm going to go read the documentation to see how this works. Oh. God, it's been such a long time since I've done Python programming. Like months. That works, right? You can unpack an array with, yeah. Wasn't sure if you could do it with arrays or just tuples. It's been a little. So I'm going to go look at the documentation. I guess I'm going to need to import sys as well to get argv. Documentation, here it is. Reading. Create a reader object, then call ping.read to extract the size and pixel data. You can take either a file name, a file-like object, or a sequence of bytes directly. So ping reader equals ping.reader. File name equals file. Width, height, rows, info So what I'm now going to do, okay, it returns them as, the row itself is an array, but in general, any suitable sequence type may be returned by read. The values in the row are all integers less than 4 because the image has a bit depth, which I see. Okay. So, what are we going to do? We're going to iterate over the rows. We're going to create an, we're going to do a couple of asserts. Assert width equals 8. We're going to assert that height mod 4 equals 0. That just makes sure that things are like in the right format that I'm expecting. We're then going to iterate over the rows. Brick equals row equals 0. We're going to iterate over the rows, and every 4 rows we're going to cut a brick out. Might be easier ways to do this with iter tools. There's probably an easier way to do this with iter tools, actually. Let me pop this open. Like I think, if I recall correctly, there is a recipe that does this. And iter tool is definitely going to be useful for getting all of the different combinations. Iter tools recipes. Yeah, here we go. Could swear there's, yes, collect data into fixed length chunks or blocks. That is what I'm looking for. So let's get that. Let's just copy and paste that in. Not even going to sweat this. Iterable, iter times n, and I do need zip longest as well. So, iter tools import zip longest. I believe that should do it. So then I can actually get rid of all this stuff. I can just say bricks equals grouper rows 4. So this just groups every 4 rows into a brick. We're going to end up with like a list of lists. So next, what do we have to do? Next, we need to do the thing where we write every possible combination of the two. I believe iter tools can help here as well. So basically, if we have like 0, 1, 2, we want to write down 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2, like that. So that is going to be permutations, no, product. A, A, B, A, C, yeah, there we go. So we want to use the product iterator, or iter tool. And the only trick is that we also are going to need to insert blank spaces. Because this is going to pack all, if we just output them like this, it's going to pack them all together. And we don't want to do that. What we want to do is we want there to be a whole bunch of blank spaces in between these two, where it includes like all of the other numbers, so to speak. What's a good way to do that? What is a good way to do that? It might actually end up making using this whole permutations thing a little too difficult. Unless I just, yeah, it might end up making these permutations too difficult. Well, I suppose what I could just do is I could just insert up to 16 blank tiles. And so that way it'll just automatically generate those as well. That's probably for the best. Is there like a nice iter tool to do that? To like just sort of pad an array, or pad an iterator, so to speak? Not cycle, it's not an infinite one. Iterators terminating on the shortest input sequence. Like I could chain it. I could use a chain of some kind. Maybe there's in fact a recipe for this as well. Return iterator of the last n items. Returns the nth item. Count how many times the predicate is true. Returns the sequence elements and then returns none indefinitely. I don't want to do that. Yeah, I think, okay, so what I'm going to do is I'm going to take the bricks and I'm going to convert that into a list. And then I'm going to just manually pad it. Or I could combine or I'm just looking for the nicest way to do this, really. Yeah, I guess it makes sense to make this a list. Like I'm going to need to make it a list. And so then bricks equals bricks plus let me just check this real quick. None times 5. Yeah, that's what I thought. Times 16 minus 1 bricks. So this is what I'm doing here. Let me see. Actually, 1 second. X equals 1, 2, 3. That's what I thought. Okay. So what I'm doing here is first I group every 4 rows into a brick, and then here I am adding empty bricks until we have a total of 16 bricks, which is the maximum number of bricks we support because we use 4 bits to define a possible brick. So that means that we're going to have 16 bricks total, and then I just need to output all of the permutations of all of the bricks. All the length 2 permutations. And probably the easiest thing for me to do now is to actually write out a new ping instead of trying to do both conversion and the width is going to be 8, height is going to be it's definitely going to be, I can just compute it manually. It's 256, 16 times 16 times 4. Because 16 different types of bricks combined with 16 other different types of bricks, 4 times 8. I think that's right. I don't know what size means here. Grayscale, default, alpha, false, bit depth. I believe for the sake of conversion, the thing that I want to do is you always use 32 bits. Is that in? Okay, it doesn't actually document this, but I think I want to use 32 bits because that'll make the conversion process easier. Anything else interesting? Transparent? No, I don't really care about most of these things. No, I could. Was that you or was that a horn outside? Must have been you. You announced your presence as you walked in. There we go, and we got a cat again. Everything is better now. Ramp. Oh my gosh. So, and then right expects a list of rows. Nelly likes being Internet Star. She sure does. So now I'm going to, oh my gosh. So now I need a file. We're going to be writing a binary as f. We're going to write to f a list of rows. So right now we've got a list of bricks. So what I then need to do is I need to do I actually use product? Oh yeah, I want product. That's what I want to be using. Product. We're going to take bricks. Whoops, not you. Let me just try this out real quick. I want repeats. Why would that be the default? Whatever. Repeat equals 2. So then that's going to generate tuples. Each tuple is going to contain a pair of bricks. Brick pairs equals products. And then what do I want to do with each pair of bricks? The easiest thing to do, and is that order going to be, that order should be right, yeah. So then probably the easiest thing for me to do, there could be ways of making this nicer. Hi, Nelly. Oh, baby. Yes. 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 For brick 1, brick 2, and brick pairs. I think this is pretty readable. So maybe I don't even need to. That's pretty readable. So we're going to take these 2 bricks. And each of these bricks is a list of rows. So all I want to do is combine them. Brick 1 plus brick 2. So if I have like plus 4, 5, 6, yeah, that's going to get us the list of rows that we want. And then we automatically are going to close it. So I suspect that this will do the right thing. I guess we're going to find out in a second. Yeah. Oh, baby. Exit. Let's find out. Python, call it make tileset.py. I believe tileset.ping is my in file, and complete.ping is my out file. Expected to. Too many values to unpack. Right. Empty brick is not defined. That also checks out. Let me double check that this is correct. 0 times 8 times 4. Yes, that looks right. There we go. Each bit depth must be a positive integer. Wait, I can't do a 32-bit. This must be defined in terms of bytes, inexplicably. Expected 8 values, but got 32 values in row 0. And that is where in right, brick 1 plus brick 2. Yeah, that doesn't check out. So just add some more asserts. Equal. Let's see where things break. Yeah, okay, so that's not correct for some reason. Why would that not be correct? Let me open up tileset.ping. This will work. Oh, it totally worked. Yeah, so this is 8 pixels wide. I'm just going to keep adding some asserts until I can figure out where my mental process is broken. So I am going to assume that the length of bricks is equal to 3, because there's 3 bricks here. I'm going to assert that the length of bricks at 0 is equal to 4. And I assert the length of... Oh. There's just too many nested arrays. I'm starting to lose track of them mentally. So the length of the first brick is 0 because it's 4 rows, and then the length of the first row of the first brick is 8. Are all of these things true? They should be. It's not true. Okay, so maybe row data is not necessarily equal to the width. Oh, I see. The bit depth is per channel, I think. Maybe. Damn it, why isn't this documented properly? Jeez. Are these pixels or are these value RLS? The image has a bit depth of 2. Like, I would think that, like, why isn't the row data isn't specified anywhere? Okay, so this says that the row is that it's 32 by 32. 1, 2, 3, 4, 8, 16, 20, 24, 28, 32. 4, 8, 12, 16, 20, 24, 28, 32. So this, no. Okay, so they are pixels because the image is 32 pixels across. Let me print out some debugging information. Tell me about the info about the file. What do I see if we do that? Grayscale false, alpha true, planes 4, bit depth 8. Interlace 0. And let me actually also, let me just print out. This is probably not the most instructive thing to print out, but it's a byte array and it's all FF. And there's, right, it's 32 because it's 8 across and 4, got it. So can we specify, yeah, let's do that. I think this will be correct now. So now this is the correct format that we want. Let me think. Expected 8 values, but got 32 values in row 0. Why are you like this? Why are you like this, ping library? I'm just regurgitating the data that you're giving me. Like, that's all I'm doing. Maybe there's more detail here. Bit depth 8. Size 8 by 12. Correct. Grayscale false. Planes 4. Like if I print out brick 1 plus. Oh, this is, of course this is wrong. I want to print out, or no, wait, hold on. I want to print that, hold on. Let me print this out. Let me see what this says. I mean, that's hard to read for one thing, but also that's not quite what I expected. What is the type of that? That is a tuple. I'm a little surprised that it's a tuple, actually. I would have expected. So each thing is a tuple. Print type bricks 0. Okay, so each brick is a tuple. That is it's probably fine though. So poorly documented, my God. Because yeah, you can see there it's giving 1 byte for each pixel data, or for each thing. So I would think that with 4 planes and a bit depth of 8, which is what we've got here, it should expect and 8 pixels across. It should expect each row to be 32 pixels across. You see that here it says it's 3, 2, and here it takes in actually 9 values. Chop these off and see what happens. See if this just works. Expected 8 values, but got 32 values in row 0. One of the nice things about having code available is that you can read the code and figure out where your reasoning is failing. check rows. VPR. VPR is self.width times self.planes. Planes equals. At the moment, the planes argument is ignored. Cool. Cool. What? Oh, and what's grayscale? Maybe this is the problem. What's the default value for grayscale? The default is true. Got it. That is the problem. It's assuming that... That's a dumb design. What? Grayscale equals false. That should do it. Well, expected 24 values, but got 32 values in row 0. At least that's a thing. Oh, and I need to say like alpha equals whatever we got here. Where is it? Alpha equals true. Row supplied does not match height. Oh, do we have to write it all at once? Okay. Well, if we have to write it all at once, write a ping image. Okay, then in that case, and basically I'm just going to yield F. To a product. Yes, Nelly? So I need to get the product of all of the bricks. And that's going to be these pairs. I guess I just flatten that. I know there's something in editor tools that'll help me there. I probably need to double flatten actually, because these types are getting so hard to reason about, but let me get flatten in here. So I'm going to get flatten or chain in here so that I can flatten it. So let me see if I can. Yeah, we can't do this. We just need to write. I think I want to double flatten. So I'm going to flatten the product to get all of the different. Or first I get the product, which gets these tuples, each which contains 2 bricks. And then I flatten it, so I just have a list of all of the bricks. And then I want to flatten again, so that way I'm going to wind up with just a list of rows. I think that's going to work. It's kind of wild, but I think that'll work. Of course, I've been saying that for the past half hour, so. Do I have a, oh, whoops. Why is that invalid syntax? What's going on here? Do I have an extra, oh, I forgot a paren. Expected 32 values, but got 8 values in row 28. Oh yeah, because I want this to be 32 now. String object cannot be interpreted as. Why am I doing? Why? There we go. Easy as pie. Let me open up complete.ping, and we're going to take a look, and we're going to see we have 0, 0, 0, 1, 0, 2, 0, 1, 0, or sorry, 1, 0, 1, 1, 1, 2. These are all garbage, but it's okay. And then 2, 0, 2, 1, 2, 2, and then more garbage. Just every possible combination. So it's very large. Is this going to fit into VRAM? I mean, what's the height here? It's 2048 pixels. Which divided by 256. Sorry, 2048 divided by. Right, it will fit into VRAM, except, oh god, I rebuilt it, right? Reload ROM, run, yeah. Except that I actually, oh yeah, okay, no, that'll, oh yeah, that won't quite fit into VRAM because I actually only have half of the bits that I thought I had, or bytes that I thought I had. I only have, got it. That's okay though. I can just use some more magic. Some more itertools magic and just drop the first or the last n digits. Just drop the last 128 tiles. Take the first, yes, I want to get take, which does mean I'm going to need iSlice. Right, so this is the list of bricks here. I'm going to use some temporaries to simplify this here. So brick combinations equals that. Tiles equals flatten brick combinations. And then I'm going to also just only take the first 128 of these. So that means that I actually only have the height is just going to be 1024. 16 times, no, not 16 times, 128 times 8. So we're just going to take the first 128 tiles, and then rows equals flatten tiles. Right, and then we're just going to write out the rows. There we go. Bada bing, bada boom, super easy. I gotta close paint. close. Row supplied does not match height. So do this, flatten. Did I do my math correctly? Yeah, 128 times 8 equals. So I'm doing something wrong here. Assert the length of the brick combinations equals 256. Whoops. Okay. Yeah? Nellie, come here. Come here, baby. Oh, yes. Hello. Hello. You're back online. We got a cat. We got a cat. I don't know if you actually want to be up here. I'll give you lots of love and pats so that way. You definitely want to be up here. Oh, right. That's the problem. So we get the list of brick combinations. Bricks equals flattened brick combinations. Right. And then we want to tiles equals flattened bricks. God, I think that's right. No, it's not right. I'm a little surprised it was working before, actually. It seemed like I was making a mistake there. So, God, I wish I had some types right now. Jeez. So, brick combinations. That's going to be like this list. It's going to be like brick 1, brick 2, brick 1, brick 3, and on and on and on. Oh, bit B. So then what I want is bricks is going to be brick 1, brick 2, brick 1, brick 3. And that's going to be row 0, like that. Right. So what do I want? I want to take, it's a little confusing, but I want to take, uh, 256 bricks. Rows equals, yeah, there we go. Don't want to flatten anymore. Super confusing. I mistypes, but there it is. Nope, does not work still. Row supplied does not match that. Oh. I've got a typo. That should be correct. Famous last words, of course. And that will fit into VRAM. So we're limited to 8 different kinds of bricks. And we're going to have a bunch of empty space. Oh, but that's okay. Bye, Nelly. Bye, Nelly. Git add git add make tileset.py. And now I'm just going to use that, I guess. So now that I've got complete.ping, .ping, I'm going to type in /RGBGFX, I believe is the name of the program. And it is, I don't want to do any of those things. I just want to give in complete.ping and all bricks.ping, I guess. It's going to be my output file. And then I'm going to go into tiles.asm and I get to delete all of this crap. And I get to just, oh my god. I get to delete all of this crap. And I get to just replace it with ink bin all tiles.bin. We hit build. Did it build? It looks like it built. And we go run, or file, reload ROM, we hit run. And we have our tiles, but we've converted them from a ping instead of drawing them in the assembler. There we go. That was a little annoying. I wish ASM, I'm going to ignore the PyCache directory. Don't want to include that in my Git repo, and we are done. Git commit and add script to generate brick tiles. 2,411 insertions. I don't know where all those came from. Oh, probably ping.py, which checks out. There we go. That is it for today. It was kind of a mess, but also successful. So, yeah, cool. Thank you for joining me. Videos are on YouTube if you want to catch up. Otherwise, I will see you tomorrow. Tomorrow we are going to... What are we going to do? Oh, right, we're going to add in bricks that take multiple hits to destroy. That was the whole point of this, so that I could add the graphics for that without sweating too much. Cool. Thank you. Take it easy. Have a very good day. I am out.